They are there.
Some of them were thinking that.
So how do I?
Just with the arrows, you can go
Oh yeah,
back
okay.
and forth.
Shall I call people to order, do you think?
Passo avanti.
Or do we want a few minutes to...
È perché è arrivata con la chiavetta.
So if we can take our seats, and we're going to start the final panel, and maybe panelists can get ready to come up, just to give people a minute to get settled.
Li ho spenti proprio. Poi al massimo vengo a accenderli. Il fotografo mi diceva che danno fastidio. Mi diceva che danno fastidio. Se li lascio acceso poi se li tirano.
No, li ho spenti anche il foglio.
Perfetto. Perfetto. Grazie.
I
have to ask you to use this one.
Rather than this?
Yeah, because the photographer is complaining about.
Okay. So, folks, you've been very good and patient. This is the last session of the day. This is the final panel, and then we'll have wrap-ups. You've all done very well in keeping going. And so you can see the title there is really looking ahead now, future directions for these models. And Jochen Chow is going to moderate this session. So I'm going to invite him to the stage, and he can introduce all the panelists. So, Jochen. You need to use that.
Thank you. Well, John just said it's tough being the last one because you are already all nearly falling asleep. So let's try to avoid this. Welcome to panel 3, Future Directions for Models. We will try to understand this in a little bit broader way. That is, we will discuss options for the work of GEM in the future more generally. And so such options must not necessarily involve new directions. On the other hand, we are at the end of the second 5 years phase and at the beginning of a new 5 years phase. So it would probably be good to have also new directions. One could keep the focus on improving the present GEM products, or one could, for instance, extend the data and models to a wider range of possible impacts. These are some of the options: extend the scientific knowledge base to indirect earthquake impacts, undertake all hazard risk research that was discussed already in the last panel actually, put a stronger focus on cities, depict the change of global earthquake risk with time and maybe a dream, project risk into the future. So these are possible options. Maybe GEM will not choose any one of these options or some of them and combine them. We will discuss these with, where's my panel? With the panel, and the panelists are Colin Jordan from British Geological Survey. He is expert on, please correct me, global geological risk. Then please raise the finger so that everybody sees who is who. You can also compare the faces, but I don't know how old the pictures are. Alex Copley, University of Cambridge, Department of Earth Sciences. His focus is on active deformation of the Earth continent. Then we have Andy Thompson from Safe Hub, formerly ARUP. Safe Hub is, as we saw already in the demonstration upstairs, dedicating itself to risk management through physics-based technology. We have Christopher Burton from Auburn University, Geosciences. He is very much into human-environmental interaction and the socio-economic component of risk. And last, not least, Roberto Basili from INGV, whose scientific focus is in earthquake geology, seismotectonics, seismic and tsunami hazard. We will have, again, like before, a first round with questions to the panelists and statements by the panelists, and then a second round where the floor will be integrated. So I will start with some opening question, maybe Colin. Excuse, no, I mixed you up. Colin, you can start. My question would be, can you comment on whether and how advanced technologies, in particular Earth observation-based exposure data technologies and the recent developments, how they can significantly contribute to improving GEM products, and should GEM really take into account the recent developments, which are quite rapid?
Can I just say yes and leave it at that, or do I should go further? Okay. The answer is definitely yes. Exposure was mentioned this morning several times, because without exposure, there is no risk. What is the hazard we're looking at, the impact of that hazard? It depends what you mean by exposure as well. I have a poster across the way, and people came across and said, what are you doing in terms of exposure? So exposure to some people can just be a building outline. And we know that people like Bing have released 124 million building outlines using their cloud engine during the year for America, which is all well and good. USA has a very good high-resolution satellite data coverage. But what we're looking at is exposure for countries that have risk and maybe are data poor. So we're looking at how can we build robust data sets for a global community who need to improve lives and livelihoods, who have issues with these hazards. And this is when I'll give a plug for what GEM is doing with the project that we're coordinating at BGS. This is looking at, it's called Meteor. You may have heard it a few times today already. This is looking at the building national hazard footprints for landslides, floods, earthquakes, and volcanic activity, looking at how those hazards interact, cascade, and then looking at the exposure that those hazards impact upon. So looking at new methods with ImageCat in the States of building exposure, and with remote sensing, we can actually build exposure data and look at homogeneous areas of building types, and then use those to understand with new vulnerability curves how those buildings are affected by these cascading hazards. So this really shows, in some ways, the next steps for where GEM could be going, how they can use their protocols, their expertise to look at that level of exposure, look at that vulnerability, and how those earthquakes interact with other hazards to impact upon the community. I just want to say one final thing, because I know I've got 3 minutes. Vitor, are you in the room still somewhere? Are you around, Vitor? Vitor, I'd like to just congratulate GEM on all the work they've done, and Vitor in particular, because I know you've been doing a lot of work building up to this global release. But Vitor is also on the GEM project, as are several from GEM. And as the PI of Meteor, I've been handing him saying, I need your active database full, so I need your geology, I need this, need that. And a few days ago, Vitor emailed me and said, Colin, I hate you a little bit right now. So that means that GEM is doing its job. It's actually working really hard to look at the global community, but looking at the stakeholders who are looking at national issues as well. And they're working so hard to release global data, but not forgetting everything else they're doing. So congratulations to GEM.
I will add a second question to you, sorry. You will get your questions. So do you think that these techniques, these advances in remote sensing are already good enough to really capture the dynamics of exposure? And if yes, at what scale? And if no, okay.
Again, it depends how you define exposure. It's quite easy nowadays to build databases of building footprints. We're working, for example, with Humanitarian OpenStreetMap, Kathmandu Learning Labs, and OpenStreetMap in Kathmandu and in Dar es Salaam to collect new data. They already have databases that we can ingest. Using AI and cloud computing, you can build new exposure data quite easily if all you're looking for is building outlines. But it's that next stage of what is that building made of and how is that then impacted by the hazards that is the more complicated step. Okay. But we're getting there by using techniques to look at, say, clustering buildings, and by clustering similar buildings, what are they then made of? But there is an issue with calibration and validation and not overselling the results as well. We can certainly make exposure data sets far more quickly than we could 5 or 10 years ago, and we're aiming to build those more quickly and have them more appropriately designed. But one thing we're doing in Meteor is looking at the uncertainty of the results. So we can look at the uncertainty of each hazard data set, look at the uncertainty of the exposure, and look at how they interact and permeate through to the final result. So the answer is yes, but no.
Yes, but no. Wait a little bit.
Yeah, wait a little bit. Keep people teased, yeah. If you pay me more, we'll do more.
Have it in mind.
Yeah.
Thank you. Alex, should advancing the understanding of earthquake sources and the active deformation of the Earth's continents, that's where you are deeply, should that be very important in the future for GEM? Should GEM take the advantage into account? Do you want stronger cooperation with GEM in that field, or what are your suggestions?
Yeah, so that's a definite yes on that level, in the sense that one of the things that's going to, I think, drive the evolution of the GEM model through the future is going to be improvements in our understanding of the earthquake sources that go into it. Because as we all know, the results of these kind of models depend fundamentally on the earthquakes you're putting into them. And GEM did an absolutely fantastic job of gathering together what's currently known in all these places and putting it into the global model. But there's a couple of things that are going to evolve this in the coming years, I think. One is that there's now a massive availability of new data that's coming online. Huge amounts of Earth observation satellites are gathering data that are going to allow us to make really, really accurate strain rate models across entire continents. So this is essentially filling in the gaps between the GPS sites and the GPS-derived global strain rate model. And also optical satellite images that are allowing us to sort of identify active faults, make very accurate elevation models of them to estimate how much motion they've had on them, and allowing us to target fieldwork to go there and ground truth the observation and collect the information that will allow us to say something about the earthquake characteristics like magnitude and recurrence interval and this kind of thing. The second thing that I think is going to develop our understanding of the earthquake sources in the future is going to be addressing some underlying conceptual issues. So there are a couple of quite big open questions in the world of earthquake science. Things like, do given earthquakes on a fault happen in the same way over and over again? Or might the next earthquake on a given fault be different to the previous one? So in other words, how well can we use the historical record to say what's going to happen next in terms of earthquake on a fault? This plays into this whole idea of, well, you know, where are the earthquakes? Are they always on the obvious fault that we know about, or are they on other structures as well? We often get surprised by earthquakes in a given region that are not on the fault we thought they were going to be on. And then this generally all follows through into just a wider issue of how much of the total motion across a fault zone is seismic in earthquakes, or just gentle aseismic sliding of faults, or perhaps distributed deformation like folding. So these are all a range of conceptual issues which then build into this idea of, you know, how do we use the information we have to actually assess hazard? And I think addressing these conceptual problems is going to be one of the things that's going to drive hazard models in the future.
Oh, great, thank you. Andy, we have heard about the rapid developments in remote sensing that might be a little bit later, not directly become important for GEM, but there are other fields where you have rapid development, and one of the fields is the field of mobile low-cost sensors and the installation of many of such sensors in buildings. Is that of any relevance? Could that be of any relevance for GEM in the future, for their work?
A leading question. First of all, great to see several colleagues from many years ago. I was a structural engineer with Arup when I first became associated with GEM, and really enjoyed the interactions, and it's really great to see everybody again, and congratulations very much so on reaching this milestone. I've always had a strong passion for, as a structural engineer, for the building-specific risk and understanding that building-specific risk, but I've also had a passion for the financial management of that. The financial management is usually done at the portfolio level. The building-specific is normally done at the building level, and marrying those two together, or bridging that void, I've always seen to create great value, and I've always been very passionate about that. And I've always seen that GEM really gets that, and that was one of the drivers for us at Arup to come into the GEM community. I left Arup to start Safe Hub with Doug Fraser, really with that in mind as well too. But to really scale that thought process using technology that you could get a better understanding of the risk of the building before and after earthquakes, and then incorporate that into a risk model at the portfolio level that was scalable to that portfolio level. Now, in terms of what we have done, I'll just show you this here. This is the device here for those of you in the live demo. It's very easy install, cellular based, very low cost, and the whole idea is to get it out there, keep it simple, get it out there, and start collecting data. Now, in terms of work with GEM, I think there's a very natural fit here. A, because of the understanding or that bridge of gap between building specific and engineering and at the portfolio level. But also, we're measuring physical properties, and we need a model, a portfolio model that is physics-based. We're physics-based, and we need a model that's physics-based that can take and incorporate our data and be able to not only look at it at the building-specific level, but also look at it at the portfolio level. And from the very first conversations that we had with John and Vitor, it became clear that there was a lot of synergy about what we are doing and what OpenQuake and the tools were able to do. So we're in advanced discussions about starting a project together that we can begin to look at. Now, in terms of...
Would you think that side effects in 5 years from now or in 10 years from now would have to be considered by GEM in a completely different way than it is considered now? Now we know side effects are soil effects, but we also know that energy is given to the building is giving back energy to the soil, and this is a very complicated thing. We are trying to calculate this, and which is very difficult, and put it into risk assessment. But if you have a whole city with, let's say, hundreds of thousands of such sensors or even more installed, would one then just have a combined building soil side effects which one could enter into such risk assessment tools?
Yeah, so risk is dynamic, and we view this as something that is continuously changing. We're measuring the response of the risk of the building before, and then measuring the damage afterwards, and over time being able to look at a series of events, small earthquakes over the course of time, being able to aggregate those into a much better understanding of the way that those buildings are responding, into understanding a much better way in which the side effects for that building are responding, and then being able to look at the frequency of the soil, the frequency of the building interacting together, and really be able to sort of view modeling as a dynamic thing that is continuously updating, continuously improving, based upon sensors that are measuring response, measuring soil on an ongoing basis globally. An earthquake in Japan updates the entire model almost instantly based upon what is being sensed there.
Thank you. Chris, everyone says the socio-economic component in risk assessment is important, but does everyone know what it means? And what do you think GEM should do in that sector in the next 5 or 10 years, and what can be achieved in that sector, and what has to be changed?
I think to effectively answer this question, I've got to bring you back into the past a little bit, to about maybe the year 2011, when I first sat down and had a meeting with the then Secretary General, Rui Pino. And we were talking about how to effectively measure risk, and you really need to account for hazard, but also buildings and infrastructure, but also the social aspects of risk as well, because if you didn't have people putting buildings in certain places or building in a certain way, you technically wouldn't have risk at all. And then he went on to talk about what GEM was doing as far as the modeling of the seismic hazard and the heavily engineering-based modeling of the seismic risk. And a lot of social scientists at that point would have run out of the room. Because integrating social issues with this is in many ways a monumental and almost impossible task. And I'll explain why as I kind of get into this a little bit more. But one of the things that we decided to start with, which was low-hanging fruit, was modeling social vulnerability. And I define that as characteristics within social systems that create the potential for loss. So very similar to physical risk definition, but in characteristics in social systems. And this can be measured. It can be measured with indicators and indices, and it's been done in the past. But in doing so, one of the problems that comes up is essentially the drivers of social vulnerability, let's say at the country level, are very different from one country to another. So you cannot even compare Nepal to the United States, for example. But also the drivers of social vulnerability from one city to another, and even maybe at the sub-city levels within countries and within cities are going to be quite different.
From today to tomorrow.
And from today to tomorrow. And so this is one area to continue along the lines of where GEM is working, but a lot more case studies, and especially working with stakeholders is a low-hanging fruit, because GEM has this huge network. So working with this network to really understand what are the different drivers in different regions of the world. Now, the second issue with this is we're talking about indicators, and usually this is measured with census type of data or data that the World Bank has produced. But can you really measure aspects of social issues like governance or culture with an indicator? And in a lot of cases, the answer is no. So GEM developed what was referred to as a resilience performance scorecard, which works directly with stakeholders. And to understand where gaps in the resilience of specific cities are by gathering city officials and community members. So this creates another issue where we have hazard on one end, and then we have risk, we have social vulnerability potentially measured, and then we have this more qualitative type of data. And how do you combine those four different elements to be able to communicate risk to a stakeholder? And I don't think we're quite there yet, and that's one of the areas that's low-hanging fruit for potentially the next couple of years, is to work directly with stakeholders to really understand what they need and how do we combine this data, whether it be quantitatively or separate maps or in some way to really communicate risk. And so this is the short term. In kind of the medium term, I really liked Murray's presentation because he brought out recovery. And one of the things that we've done is develop tools to try to predict recovery outcomes, so decision support tools. And then this was done through funding from the California Seismic Safety Commission. But we have one case study. And of course, the drivers, and this was a case study of an earthquake that occurred in Napa, California. But a lot more is needed to be able to inform this tool. And so we really need to be paying attention to potentially not just recovery from earthquakes, but from other perils, because we have floods a lot more often than we would have an earthquake. And same thing with tropical cyclones, for example, in the US, and potentially there's low-hanging fruit to really try to understand drivers of recovery and develop these tools more. And in the long-term space, I think a good place for GEM to be would be to start looking at other issues of social and economics. And potentially some of that is dealing with cascading effects. I heard that come up. And also in areas of food, energy, and water. And when I say this, I'm not necessarily talking about calculating the risk, but understanding what is driving resiliency within food, energy, and water systems. And where do we have cascading effects within those systems, and how do we close resilience gaps? And also within supply chains as well. So potentially that could be a long-term avenue to look at as well.
Thank you. You already mentioned other perils. Roberto, in the other discussion panels, we already heard about multi-hazard, multi-risk, and it's very important. And what do you think? Do you consider it worthwhile for GEM to expand its scope to other than earthquake perils, and for instance to tsunami modeling, which would be very closely related to the earthquakes or maybe landslides? And what could a global tsunami model get from GEM and vice versa?
Yeah, okay. Well, I think that this question can be answered from different viewpoints. For an organization like GEM, one of the viewpoints is the management viewpoint, and this is something I won't be able to answer. From the technical and scientific viewpoint, instead, I do see, well, first of all, a big opportunity for an organization like GEM to expand its scope in other earthquake-related hazards. I think it would be very natural for an organization like GEM. But I also remember my personal experience with GTM, getting to tsunami, for example. GEM was definitely inspirational for the tsunami community. Looking at what GEM was doing was like, well, we went to be somehow like that, not necessarily exactly like that, but embrace this this challenge to get a common global tsunami model and embrace the Sendai framework as well, and contribute to the multi-hazard risk assessment. And at the same time, and getting specifically to tsunami, in the probabilistic tsunami assessment discipline is very young compared to PSHA. And so the community, the tsunami community has been borrowing many of the concepts that were developed previously in PSHA, and still, and getting to the second part of your question, the global assessment report, the GAR-15, already used some of the GEM product. For example, the global subduction characterization database, and that was used in that project. And so there are several points of a connection. Some of them are rather obvious because of the similarities, at least up until the development of the seismicity model, as long as we think about tsunami generated by earthquakes. But then we have to think about that tsunamis can be generated by other type of sources, and things get more complicated. But even if we remain within the scope of the tsunami generated by earthquakes, there are some differences in how you develop the earthquake model for the tsunami generation that so far is made in a very similar way as in PSHA, but the community of the tsunami model is starting to make it a bit more complex based on the evidence we had from the recent tsunamis. So if we think at Tohoku, for example, the part of the rupture that contributed to the ground shaking in Tohoku, it's in a different part of the subduction zone from the part that mainly contributed to the tsunami generation. So these complexities are very challenging, and it's not straightforward to borrow models developed for seismic hazard into tsunami hazard. And I think that this would be the main difficulties, and widening the scope of GEM, I think that the first step, I cannot tell what can be done in some years, in the years to come, but something to start with would be to interface with the communities that already got inspiration by GEM in building global organizations like yours.
But this has already been done as far as
Yeah,
I
yeah,
know.
I mean,
and that's,
yeah, just
but-
something
so
to
that's a
keep
good
alive
start.
and
Yeah,
carry on
yeah,
with that,
yeah.
because I think it would be mutual, there are mutual benefits for the organization and for GEM as well.
Well, thank you very much. We are opening the discussion to the floor. And there are the questions somewhere. Oops. Some of the questions. You need not try to answer these questions, but some of the questions. When you talk about the future of GEM, then you have to find out some shortcomings of GEM so far. I know GEM has done incredible good work, so please don't misunderstand me if I talk about shortcomings now, but if you think about the future, you have to get some idea on the shortcomings. And I remember this morning, John, you were showing a slide with showing two main shortcomings. You said the maps and the models, they are mosaic, that was one thing. And the second, they are a snapshot in time. I think that was on one of your slides. And these, to my feeling, are two really very important shortcomings, but that shortcomings that show us in which direction probably one should go into the future. So we saw a comparison between risk in different countries, which was shown by Vito this morning. But my question is, do you think that with a mosaic, you really can compare risk? And is comparison of risk between different regions, is this an important goal that GEM should reach? Please give your opinion, also your. Yes. We need
Okay,
some
actually, I have a microphone.
Oh, yeah.
So I'm going to use it. So I have a proposal for a future role for GEM, which I'd like to put in front of your illustrious panel. And that is that in the Sendai framework, the first goal is to demonstrate that we can reduce casualties by comparing a 10-year period from the 10 years leading up to 2015 with the 10 years leading up to 2030. And we know that even at an international level, even at a global level, this doesn't work. You can't simply empirically demonstrate you're making progress because there's too much volatility in the casualties from extreme disasters. And we've actually written and published a paper on this, that you'll tend to get spurious results by attempting to use actual empirical data. And once you come down to individual countries, if you look at Haiti, for example, between 1900 and 2000, fewer than 10 people were killed in earthquakes, and then in one afternoon in 2010, more than 200,000 were killed. You can't simply take a sample of data at either an international level or a national level and demonstrate you're making progress in reducing disaster casualties or even disaster economic losses. You have to use risk modeling to tell you this. And it seems to me from what we heard this morning, in particular, the excellent work on exposure and risk that Vitor was presenting, we absolutely are poised to be in the situation where we can start measuring whether we are making improvements on casualties by country, by city, simply by risk modeling. And the key is, when developing exposure data, give it a vintage. So in the same way, good wine, give it a vintage, don't mix it up, make it specific to a particular year. So you make the exposure data of the year 2010, the exposure data at some date in the future, and then we can compare, is the risk going up or down in a particular country or worldwide by actually employing all the capabilities you now have. But you absolutely need to keep your exposure data, don't mix it up across the years, make it specific to 1 year, and then revisit this every 3 or 5 years to undertake risk auditing, independent risk auditing to actually show, are you making progress or not? You don't have to wait for a disaster to happen to tell you whether you are or are not making progress. We have the modeling capability now to do this, and I think independent risk auditing is a key area in which GEM could potentially move and become the risk auditor of casualties initially from earthquakes for the world. And I think that would be an incredibly powerful role. I think it would actually solve the problem that Sendai has set. It set itself a methodology which actually doesn't work, and here is an opportunity really to, for the first time, to measure real progress in disaster reduction.
So you address actually the second shortcoming. That means the snapshot in time. So we need to get some information how exposure and these things change with time.
Absolutely, yeah. I mean, these need to be real snapshots and that don't mix them up across the years. Make it pure, make it specific to a particular year, and go back and revisit it with the same model. I mean, one criticism of this is if you change the model, then you'll change the results in the meantime.
Yes,
if you have a new model by 2020, you go back and revisit your 2015 exposure and compare it with 2020 exposure with the same model. So it's not model error or model change that is contaminating your results. But then you'll find objective proof as to whether countries are or are not making progress. And at present, I mean, there's no way of establishing this.
Yes, please. Fabrice.
Thank you, Johan. The question of harmonization of the model compared to a mosaic model is a very important one, and it has been discussed a lot those last years. For sure, you're right. I think if we are using a mosaic model, the working hypotheses which have been used by the modelers in different parts of the world are different. And we know that our models are full of uncertainties. So I think I agree with you that we cannot so easily compare the risk result from one part of the world to another one if we are using a mosaic model. I think the second major weakness of a mosaic model is the fact that a mosaic model is not testable. In order to test a model, we need to remove the ergodic assumption. So we need to replace time by space. And for that means that we need a kind of harmonized model to really make the model testable. This is the two major weaknesses of a mosaic model, but as discussed this morning, this was the first step, which is already, as shown this morning, a major step. But I think you're right. Moving to a full harmonized model will present some two main strengths, going to something which is testable and going to something which allows the comparison of risks on different parts of the world.
Is it feasible to move to a harmonized model? I mean, it's easy to say, but is it feasible? Who knows? Well, it's just a feeling that it may be very complicated, actually, and you have to really consider many things. It may be very complicated. Yes, there is a...
Returning back to this space and time thing, obviously the last 10 years, GEM has given us the spatial dimension, and to reiterate, it's moving to the time dimension for the next 10-year challenge and goal. And that's not just updating the exposure model, not just updating the faults as we find more of them to give you the sources, but it's actually what I put to the panel is how do you incorporate two aspects at a time? Say you have a major earthquake, how do the fault interactions and the stress changes get incorporated, and also our knowledge of the earthquake cycle. For these major faults, as we get further through the earthquake cycle, we'd expect that to change it. So is that something that we can reasonably incorporate in the next 10 years to move away from this static picture?
Yeah, thank you.
Sorry, can I come in on an answer to that?
Yes, please.
Can I come in on an answer to that?
Sorry, I thought it was him.
One-
Yes. So.
A quick answer. It isn't just the earthquake side as well. You mentioned that. It's also when an earthquake hits an area, as we've had the recent example in the Gurkha earthquakes in Nepal, that destabilizes the salt sediment as well. So when the monsoon came, it was more prone to landslides. So it's a series of issues like that as well. And I think what we're getting a discussion around is the challenge of understanding if we can have an impact as a group. And I think risk is certainly increasing. One of the countries we're working in, Tanzania, Dar es Salaam, is the fastest growing city in Eastern Africa. It's got a population of 4.1 million today, forecast to increase to 21 million by the early 2030s. So it's going to grow very quickly. So clearly the risk is increasing. Certain hazards are also increasing. Landslides are increasing because of climate change. Are there more earthquakes? I'm thankfully not an earthquake geologist, so I can't answer that question. But we have an issue that I think the timestamp is an excellent way to look at that. If we can isolate timestamps and model the impact that we're having in terms of understanding the impact of those, that is a great way to see, is GEM providing an answer that is a solution. I was at a poster earlier on today and I was asked by one of the people from the insurance industry that what they want is evidence. They want to say that the results that we're producing as a group can be used to make properly informed decisions. And that is a major challenge going forwards. But are we going to make steps towards that in the next 5 years? I think we're showing that we can make those steps.
Yes, please.
Yeah, so just to pick up on John's question, certainly time dependent has to be key in this on some level. On the most basic level, some earthquakes happen, you get some aftershocks and that decays. Some earthquakes trigger other earthquakes almost instantaneously, for example, as happened in Kaikoura in New Zealand, where a whole fault network essentially broke instantaneously. And then some earthquakes trigger other events over a sequence of months or years afterwards. For example, the central Italy earthquake sequence that triggered a series of events over a course of months. So the question is, how are we ever going to sort of understand that on a global level? And we simply don't have enough time or ability to investigate every single fault system to come up with an answer to this, which is why we need to pay really close attention to the ones that we have seen and try and understand the underlying physics of this. Why do some earthquakes trigger other events and why do some not? It's only by actually understanding the process will we then be able to transfer it to other places. And this kind of follows through into the previous question and comment in favor of a mosaic approach in the sense that the fundamental underlying observations which are the earthquake sources that go into sort of one aspect of these models, these are never going to be homogenized in the kind of timescales that we're talking about in GEM. It takes an unbelievable amount of time and effort to do a careful job of what's happening on a given fault system. If we were to homogenize to the basic level of information we have everywhere, then it would not be a very good model. So some places we do know an awful lot and it would be mad to ignore that. But equally, we don't want to try and claim we have that level of knowledge everywhere in the world because we simply don't. So I think embracing the idea that we know more in some places than in others and taking a kind of mosaic approach in many ways has a lot of advantages in this kind of game.
Christopher, yeah?
I'll just talk about time a little bit from a social systems perspective in urban growth, simply because this could be a way for GEM moving forward into a different area as well. And one of them would be modeling urban growth, and essentially in doing so, modeling social vulnerabilities, because we can, based on the past, understand where populations may move, and then we can start to understand or potentially predict what vulnerable populations will be moving where and why. So where are the elderly predicted to go, those that are in poverty, for example. So we can really try to better understand what type of populations will be moving into risky areas within the future. But of course, that's data intensive. You need population patterns and growth patterns from the past, and in some countries you're not going to have that. But one of the tools that GEM does have at their disposal now is what's referred to as a resilience performance scorecard. And so this tool is basically for working with stakeholders and asking them questions based on the resilience in certain areas, such as legal and institutional, or the ability to mitigate. And this can be used as a benchmark because it uses stakeholders and they use handheld receivers and key in an answer based on the question that you ask. And so all of a sudden you have qualitative data that just turned quantitative. And then that can be used as a benchmark, and then those stakeholders can be brought back to the table 5 or 6 years later once they understand where their gaps in resilience are, and then potentially develop mechanisms to reduce those gaps, and do the same exercise, hopefully with the same people, and try to understand if those gaps have been closed or if there's still area for improvement. And so that's at least 2 areas where GEM can get involved with the temporal aspect in social systems research and social systems work.
So 4D risk is important. That's what I understand from all the discussions. Let me go one step further and draw your attention to the globalization of risk. I don't know whether everyone is actually aware of what is going on at the moment, that due to networking of transport systems, of communication systems, due to the global supply chains, and there is an increasing globalization of risk as a function of time, of course. And so my question would be, as GEM has the word global in its heading, wouldn't that also be something GEM could take into account in the future? We are at the moment just discussing and dreaming, so I would like to get your opinion on that, and probably also the opinion from those who would be supposed to do that. Vito.
Thank you, Jochen. I was trying to hide here on the back. So yeah, that's a very good question. The globalization that we have now, I think we've seen, for instance, the example, I think it was in Japan, that basically the earthquake in Japan then also caused delays in the stock in several other countries, which increase a lot the losses. I guess what we have could be used as just a very basic framework to start that discussion. I think the models that we have right now are relatively good, or I'll say sufficiently good for the direct losses that we have. And this is exactly what we presented on the map. It's only the direct losses. I think we do need probably collaborations with somebody that have been modeling this for a longer time. So let's say the economics across the world to understand if, for instance, the stock change that we have between one country and the other can be properly modeled. I will also say that in terms of risk of infrastructure, let's just downgrade a little bit your comment and just go only at the country scale. We do have already some demonstrations of risk on transportation networks, for instance, at long distance. The fact that regions that might not have high seismic hazard, but because the transportation network is affected, then you do have losses here. We have some demonstrations about this. And for the next working program, we have more demonstrations from Geoscience Australia, which will be actually studying also networks in, if I'm not mistaken, I think it's Perth in Australia. But going beyond this and doing this at the global scale, we're not there yet, but I think it's obviously something that we have to address.
Thank you. Any other remark? I mean, after going so far in the discussion, I should at the end come back and put your attention to the first point. Keep the focus on improving the present GEM products. There is a lot to do there. We heard about making the tools even more user-friendly. We heard about testing the models, and are there other things which you think is really important? Yeah, of course, communicating the models, you mentioned that in the morning. So what else should actually be done before we think of things like time dependence and globalization? And okay. So maybe, okay. if there is no contribution, we leave it. Please.
So I think that these discussions of future directions for GEM are very interesting, and all of it excites me, you know. And so, but as someone who's involved, you know, on a much more day-to-day level, I particularly focus on creating data sets, but I have a lot of interest in how the modeling procedures work as well, and ideas for things to implement and so forth. And I think that one thing that may kind of help us focus direction and decide what's possible, what's a good route, and how to go about accomplishing some of these different tasks is to make decisions on whether we want to, say, extend the capabilities of OpenQuake in certain directions versus build these massive data sets and build the models to do certain things. And so whether we want to, you know, be focused on data in particular avenues of exploration, be focused on, you know, model results, or be focused on just simply adding the capability, or working with collaborators who can extend the technical capabilities in some directions, say time-dependent earthquake probabilities, or you know, someone else who might come up with infrastructure things and looking at how you know, when you take out certain infrastructure, it can affect how cities work. I mean, GEM may not need to build data sets and models for all of these things ourselves within our small institution, but you know, by building the technical capabilities or interfacing certain modules of code within OpenQuake or adjacent to OpenQuake, we can kind of lay paths to doing some of these things. And in other areas, it makes sense. It may make sense to actually extend the data sets. So thinking about how these goals would be accomplished in addition to what they are, I think can help us decide where we need to go and how much resources to put into things before we know whether they'll work.
Thank you very much. We take this as the final remark because it's late already. And thank you to the panelists. Thank you to the auditorium. I hope that the governing board will have something to think in its meeting tomorrow on the future. Thank you again to everybody, and have a nice evening.